All right, if you got those, we did some finding limits using a graph, or two, or three. Now we're going to look at a table of values, and we're going to think about the function that they gave us, and then we're going to try to find some limits based just off of a table. So it says below is a table of values of an exponential function. So this is important. This is kind of what I was trying to get you guys to start thinking about this morning. A lot of times on AP calculus exam, they're just going to say an exponential function. You need to know all the properties of any kind of exponential function. So let's think. What does an exponential function look like? This is from Algebra 1. So remember, your function could look something like this. If it's a decreasing function, it looks something like this. We have a horizontal asymptote going on in either of these. So either something like this or something like this. That's what we're talking about. Is this graph, or is this function continuous? Yes, I can start from one end of it to the other end of it and never pick up my pen, right? So we're looking at some exponential function that is continuous. Looking at our numbers here, we start up at 513, and as my x's get bigger, what happens to my y's? They're getting smaller. So I'm thinking my graph looks something like this, which means I've got an asymptote over here somewhere. Or, sorry, on this side here, as my x's get close to infinity, my y values are getting close to an asymptote. Okay, so we've got that in our mind. So now, what is the limit as x approaches negative infinity? Well, as my x's are getting closer and closer to negative infinity, what's happening to these numbers? They're getting exponentially higher, right? As we get close to negative infinity, going this way, my numbers are going to get super high and we're going to approach infinity. All right, if I have a continuous function, that means I have no holes, I have no vertical asymptotes. It's gonna, as we have a limit from either side of -3. So if I'm looking for the limit of this guy here, as I approach from this side, we're getting close to 9. As I approach from this side, we're getting close to 9. So for continuous functions, it's just gonna be whatever that f of -3 is. All right, C says, what's happening at 1? Well, as I approach 1 from the left-hand side, we're getting close to 1.5. As I approach 1 from the right-hand side, my y values are also approaching 1.5. And so my limit is 1.5. All right, these endpoint ones are a little harder unless you understand exponential functions. All right, we know for exponential function, as we get closer and closer to positive infinity, what is my y values getting closer to? That asymptote. Well, where does it look like that asymptote is approaching? What are these numbers getting closer and closer to as we get further and further out? Looks like we're getting awfully close to 1.0. So the limit here is going to be 1. All right, so that is for an exponential function. And our next example is going to be for a rational function. Okay, rational functions are more challenging, right? We thought that in Algebra 2. We thought that again last year. What's true about a rational function? What are some characteristics of a rational function? Okay, so remember, those are your graphs that might say look like something like this. Right, they have 2 pieces, might have more pieces, but a basic rational function would look something like that, where you have a vertical asymptote and you have a horizontal asymptote. All right, if we look at this guy here, as we go out, it's asking us to find the limit as x approaches negative infinity. So as my x's go out towards negative infinity, what are my y's going to be getting close to? Well, as we go out this way, what are those y's going to get close to? It looks like we're starting at pi, and then we're going out to 1.0. So if I'm going to get close to an asymptote as I go further out, this is not what this graph looks like, right? I just said this might be. But as we get further out, as we approach negative infinity, the end of this graph should get close to my asymptote, and it looks like that asymptote is going to get close to 1. Good. All right. And then we've got the limit, the left-handed limit. So from the left-hand side, as we approach -1, what's happening to my y values? As I approach -1, it looks like, I'm actually going to erase this and draw what we think is happening. So it looks like as we approach, let's call this guy -1. We're starting out here at like 1, right? Here 1, which we think is an asymptote. And then it's getting, as we get close to that -1, it's getting really big really fast. And at -1, it's undefined, so I know there's got to be an asymptote here. So the left-handed limit of -1, we're getting really high, so it's going to positive infinity. The other side is asking about, well, what's happening on the other side? Well, if I look at these numbers on the other side, where are we getting close to? It's going down really fast, so it's going something like this. Now, this is a rough sketch. We're just trying to get an idea, just based on the few numbers that we have on this table, as to what's happening. So as we approach from the right-hand side, my x values get close to -1, my y values are tanking really fast, right? We went from -1 to -2,000 awfully fast, so it's going to head down to negative infinity. So this guy here is negative infinity. Okay, perfect. What's happening at 2? Well, at 2 we have another undefined point, but if we look at our right-handed limit, it's asking for the overall limit, right? It's not saying for the left-hand side or the right-hand side. Well, what are the two things has to be true about this? If we approach from the left-hand side and from the right-hand side, they have to be going to the same number in order for that limit to exist. Well, as we approach to the left-hand side, it approaches this value here, which is what? What is 0.333333 for whatever? Approximately a third, right? That's what it's looking like to me. And then what happens when we go from the right-hand side to 2? It is also going to approximately a third. So the limit is the same on both sides. 1/3 is a real number. So the overall limit at 2 exists, and it's 1/3. All right, what's happening as this guy goes out to positive infinity? What is it getting close to? Just like over here, it's getting really close to 1. So as we go out to positive infinity, this is going to be 1. And then they ask, okay, well, what's the limit as x approaches -1? Well, if we go back up here and look at what we had, remember, as we approach -1 from the left-hand side, it was positive infinity. Right-hand side is negative infinity. So this guy does not exist, because the left-hand limit does not equal to the right-hand limit. And if they were both positive infinity or both negative infinity, it still wouldn't exist. Why? Because infinity is not a real number. All right, I am going to forward a slide. No, I'm not. I'm going to scroll down. Oh, we covered everything on this page. Sorry. It's the next one that I have you try. So the next video, I'm going to do an example for you, and then I'm going to show you one. You're going to try it on your own, and then you're going to come back to class tomorrow and tell me how well you understood this. All right, look for the next video.